Hello! Today we are talking about PaLM, Scaling Language Modeling with Pathways. This paper is by now mostly a historical curiosity. It's from 2022, so it's so old, especially when it comes to the world of LLMs. But it was really impactful, and the PaLM model was state of the art at the time. So this paper came out October 2022, right around the time that ChatGPT came out, and it was. I don't know if it was the biggest model in existence at the time, but it was up there, and it also leads then to the series of PaLI models that we'll be discussing later. So it fits into the overall theme of Clip to PaLiGemma, because the PaLI models were based on this. So this is a huge paper. It's really big. So I'm not going to do it justice describing everything. But I did want to mention a few things because it was important at the time. So it is a model. It's kind of similar to GPT-3 in that I think it's decoder only. That's right. It's a decoder only setup. And it has a bunch of things that are kind of standard now, multi-query attention, and well, I don't know if Swigglue is still in vogue, but the interesting thing is that they trained 3 different model sizes: 8 billion, 62 billion, 540 billion, and the other interesting thing, or at least historically interesting thing about this paper is that they only managed to train such a big model because they were using pathways. So this is some internal Google software that allows parallel training across different pods. And that historically has been difficult, and Pathways makes it easy. So Pathways resulted in the name of this paper. PaLM stands for Pathways Language Model. And because of this, they were able to utilize more compute. So previously they were training, I'll give some examples of previous models that were trained. And they could only use 4096 CPU V3 chips, whereas now for this model they were able to use over 6000 TPU V4 chips across 2 pods. And that's important because obviously at this time everyone was finding that scaling up data and compute is the best thing to get better performance, and that turned out to be true here as well. So let's talk about some benchmarks. As I said, this is a big paper. They describe a training data set, and it all makes sense. It is a little bit scary that in the data, like half of the data comes from social media conversations, and then the rest is filtered web pages. So filtered, they describe that they sort of have a classifier to ascribe like a quality score to web pages to make sure that the high quality pages are more frequent and so on, and books and GitHub and so on. So they also include a bunch of source code. But the fact that social media conversations make such a huge proportion of the data that they trained on, that surprised me. I'm not sure how I feel about it. In section 4, they describe the training architecture, which is the whole infrastructure for how these things are trained. Not going to go into this. And what else do we have that is interesting? And then there's experiments. So in short, PaLM 540 billion kicks ass on all the NLP benchmarks. So that you can see that this column here is always bold, which is well, not all the benchmarks, but most of them. The column here, and the column here, and the column here. What else do we have? They evaluate how to do fine-tuning well. MMLU, which by now is pretty standard benchmark to do. And was there anything else we wanted to describe? I think that's it. So the paper is very, very impactful, good to know about, and it found interesting things, and the training infrastructure was also kind of cool. And I'm looking forward to seeing how it impacted later work. Thanks.